Hi, my name is Akash Bhatt, and this is my lab report presentation on Lab 2 regarding lines of charge. This lab built on the principles discussed in the previous lab, which involved charging pieces of tape and observing their interactions with other objects. This lab helped us visualize many of the different physics principles that we have discussed, including calculating the electric force, which is done by multiplying the electric field around an object by the charge of an object itself, the behavior of charged objects, which discusses how charged objects react when placed near other charged objects, and how like charges will repel one another while opposite charges will attract. The concept of excess charge. This concept regards what happens in an object when it has acquired an excess charge. These charges move to the surface of the object. One concept that we have used in this lab, which we have learned in a previous class, is how to calculate the gravitational force. This gravitational force is calculated by multiplying the mass of an object by the gravitational acceleration. On Earth, this value is 9.8 meters per second squared. In summary, we were able to visualize how charges repel each other while opposite charges attract, as well as how electric charge can transfer between objects. We were tasked with carrying out a few different experiments to observe these interactions between charged objects. The first involved charging two pieces of tape the same way by ripping them off of pieces of tape. When placed near each other, these similarly charged tapes repelled each other. The second experiment involved charging one piece of tape by also ripping it off another piece of tape and bringing it near a neutral object. The tape was attracted to the neutral object because the excess charge on the tape polarized the atoms on the neutral object. The third experiment involved charging a pen negatively by rubbing it in hair. The tape was attracted to the pen, so we were able to conclude that the tape was positively charged. Finally, we placed one positively charged tape on top of another positively charged tape and observed the conditions required for the top tape to float on the other. The top tape floated because both tapes had like charges, and like charges always repel each other. We were tasked with modeling this final experiment regarding the floating tape on GlowScript. To do this, I needed to determine the electric and gravitational forces. However, instead of treating each tape as a point charge, I was to treat the tapes like lines of charge. In the top right, you can see my calculation for the gravitational force on the tape. Below is my calculation for the charge on the tape based off of Lab 1's point charge model. This number is therefore no longer relevant, as now we need to find a way to model this with a line of charge model. The new value of Q that I got through this new model was found to be 1.5 times 10 to the negative 8, which I found by guessing and checking. In GlowScript, I needed to show how the two objects were interacting. To do this, I first created two rows of spheres to represent the two tapes on top of each other. Because we are treating each tape as a line of charge, these two for loops, as you can see in the middle of the right side of the screen, were necessary to properly calculate the net electric field on the top tape. The first for loop iterates through each charge on the top tape, and the second for loop iterates through each charge on the bottom tape and assigns a net force due to that charge on the top tape. Then I created an arrow that adds up the net electric force on each charge to create the net electric force of the whole system. This arrow is shown in white in the model screenshot on the bottom left of the screen. The system is in equilibrium at this moment, so the net electric force has the same magnitude as the equal and opposite gravitational force, which is shown here in yellow. The magnitude of the charge on one piece of tape as calculated by my computational model was 1.5 times 10 to the negative 8th power. This number was found through a process of guessing and checking. One assumption that I needed to make for this experiment is that the same amount of charge was distributed evenly along the tape. This assumption needed to be made because we assumed that the charge was evenly distributed along the tape when we made the magnitude of charge on each part of the tape in the model. Without this assumption, this part of the model would need to be reworked in a more complicated way. If we had modeled each of our tapes as a single point charge like in the previous lab, we would have found a much lower charge. As you can see, the charge discovered from this newer model, the line charge model, is much greater than the charge discovered from the point charge model. Because the line charge model properly uses superposition to represent how the electric force on each tape is affected by all charges on the bottom tape, it is more accurate, and the net y component for the E field is therefore greater. These estimates differ because the point charge model, as we previously discussed, does not consider the superposition of all of the charges on the bottom tape. Because of this, the new model, the line charge model, is much more accurate. Thank you for watching. This has been my presentation on Lab 2, Lines of Charge.